Okay. Alright, so I'm going to be going over graphing. We're having some issues in this particular topic. So this is a 6th grade topic, but we've spent over a week reviewing for this. So I'm going to make a short video to recap it. So it depends upon the relationship. So distance time, speed time, and position in time. So distance is how far you go, speed is how fast you're going, and then position is how far you're away from the starting point. Okay? So for each graph, each relationship, I wanted you to show me acceleration, constant speed, and what it would look like if it was at rest. So this is going to be a DT graph, so I'm going to put distance and time, because I want each graph in this column to represent distance and time. These are going to all be speed and time, so these are all going to be ST graphs, and we are very familiar with this terminology. And then these are all going to be PT graphs, so position and time graphs. Okay. So for this graph, I want to show that the object is accelerating, which means speeding up. That means that the distance is increasing and also the time, but at a fast rate. So in order to show acceleration, we know that that is a curved line. That is a curved line. Let me refocus here. Okay. So we should have a curve showing a fast increase. So the distance is increasing really fast, also with the time. For a ST graph, for acceleration, all I'm doing is a straight line. So if it helps, put some numbers by it. This speed down here is 0, 1, 2, 3, 4, 5. As you increase, as you move up, you can see that the speed is increasing as well. So this is acceleration for a ST graph. And a PT graph is just like a DT. So we have that curved line again, showing a fast change in distance over time. Alright, so PT and DT are very, very closely related. Their graphs are all going to be the same. It's just ST because that is speed versus time. You already have calculated the speed. To get the speed for DT, I have to do D divided by T. This is already calculated for us. So now I want to show constant speed on a DT graph. Well, that's going to be a straight line. So it may help you to put some numbers with it. 1 and 1, 2 and 2. 1 divided by 1 is going to be a speed of 1. 2 divided by 2 is going to be a speed of 2. 3 and 3. That means everywhere along this line, the person is at the same speed. Constant speed on an ST graph is going to be the same speed. The speed is not changing. So this is already speed. So if I put numbers by it, the speed is 5 whatever miles per hour, kilometers per second the entire time. So it is different from a DT graph. And here it is the same as a DT. The only thing with position graphs is that it can show you going back to your starting point because it shows your position. And lastly, we have at rest, which means the person or the object is not moving. When an object is at rest on a DT graph, it's a straight line anywhere, because that means that my distance is not changing. So this person stayed at 4 meters for this entire amount of time. The distance did not change. For you to be at rest on a speed graph, well, your speed has to be 0, which means I have a straight line at the bottom. And you may not be able to see it, but it's there. That means that my speed is 0. I'm not accelerating. I'm not moving at all. I'm stationary. 0. And then a PT graph, you can draw the line anywhere. And if you put numbers by it, the position does not change. The person stays at this position for this entire amount of time. So that is exactly what these graphs should look like. Please review them. Thanks.